Now we're going to take a look at some reactions you can use to get the ether functional group into a molecule. The first one is a named reaction. It's known as the Williamson ether synthesis. This reaction should, however, be pretty familiar because it's really just a simple SN2 reaction. And the SN2 is going to take place between the lone pairs on a negatively charged oxygen and a carbon with a leaving group. So this will start with an alcohol, and that's what we have. Here's our starting material. And then we add some base, and that deprotonates the alcohol. And then from there we add some organohalide to do the SN2. Right, so in this case I'm using sodium hydride as my base. Another strong base could be used like sodium amide. And what we're going to do is just draw out the mechanism for this. So let's just start with our alcohol. And in fact, I'm going to abbreviate that ring as just a phenyl group to simplify it a little bit for us. So we have our OH. First thing we do is add the base, sodium hydride. Think about how you can simplify these reagents. So what happens if we take sodium hydride, let's break that apart into Na plus and H minus. So it's actually the hydride H minus which acts as our base here. This will come and take this proton off of the oxygen. And that gives us a negatively charged oxygen plus the two hydrogens combined to give us hydrogen gas, which escapes the reaction flask. This negatively charged oxygen is a good nucleophile. So from here we can do the SN2 reaction. I'm going to add bromopropane, which is my second reagent. Okay, now the carbon that the oxygen will attack is the one where we have the leaving group. So that's this carbon with the blue dot on it. So I'm going to put my pencil down on the electrons on the oxygen and draw a curved arrow to this carbon. And then we need a second curved arrow showing the Br leaving as a leaving group. So what's the product? The phenyl, CH2O. I'm going to draw the new bond in red just to help us keep track of it. And then we have 3 carbons that were added. So that bonded to that carbon that I highlighted in blue. So that was the first, second, and third. Plus we get the Br minus, which will just hang out with the sodium cations that came from sodium hydride. Right, when you're doing this type of reaction, count your carbons. Make sure you don't lose any. So in my starting material, I have the phenyl group plus 1 more carbon. So I'm just going to say 1 carbon here. We're adding 3 carbons to that. So I should end up with the phenyl group plus 4 carbons in my product. Here's the phenyl, 1, 2, 3, and 4.